Hi, I'm Prasenjit Datta, and in this video, I'm going to demonstrate the financial document analyzer application, which was a part of this assignment. So first we will go through first we will take a quick overview of the how the application works, and then we will move on to the architecture design, and then we will move deep dive on the rest of the aspects. So as a quick overview, in the system, we have a React React application for the front end, and then we have a fast API server uh, that serves as the main backend server. And then we have a worker microservice, which is implemented using fast API only, and it is the one which generates the report from the PDF contents. So our worker service is also running, our main service is running, and our front end is also running. So let's sign in first. So I've already created an account earlier, so I'm going to use that. So once I'm logged in, uh, I will be able to see a list of previous uploads that I made. I can delete them, and also I can open and have a look at the report that was generated previously for that last uploaded document. So I used the financial document of Tesla, and a hold stance was generated for it. So either it can be either buy, hold, or sell. And we have the signals, assumptions, and the uncertainties. So let's upload a new document and generate the report for that. So and this is the message, question, or prompt kind of stuff which the AI will use to generate. So after that, I will click on upload and analyze, and it will create a job in the Redis based job queue, and then the worker will process it. So while it is being processed, let take a look at the architecture of the system design of this application. So as as so the firstly the main components of this I will go through the main components of this system and how it is implemented, and then we will see how the document uploading and the report generation process works. So when so there is a React client, and then we have a uh, backend server implemented using Docker, which can auto scale by using Kubernetes. And then we have an Nginx load balancer. We can also use it as a reverse proxy in the future. Right now, it's not needed because for the whole system, only this uh, service is publicly exposed with authentication and Nginx load balancer. And this worker microservice is also Dockerized, and it only pulls job from this Redis-based queue and then to its operation. So we also implemented MongoDB. MongoDB was used because consistency is not a problem right now. Much of the whole system is asynchronous based, asynchronous job processing and all that. And then we have this Redis for implemented for DB queries caching, and also when job is created and we store the job data inside the Redis, and which is continuously being polled by the backend server. And from the worker microservice, we make update to this data, job data inside the Redis as it processes the report. And then there we have a observability platform, which is based on OPIC, which we'll see in a moment. And yeah, so that's it. That's the how those that are the essential components of this architecture. Now, when a user uploads a PDF or document, it is first uploaded to the application server, and it stores the PDF inside a volume, which is also accessible to worker microservice. So once it receives the once it receives the document, it creates a job entry, and in the job base Redis based job queue, and it like starts polling its status. So the status can be processing completed or failed. And and this job entry is continuously being updated by worker microservice as the document is processed. So when a job is created, the worker microservice pick pick the job, and then using few AI agents, it performs the analysis and generate the result, and then it is saved into MongoDB. And the worker micro once the analysis is generated, it updates the job entry uh, and mark it as completed. So once we get in the job polling, once we get the job result as completed, we fetch the report from MongoDB, and then we display it to the user. And yeah, this is the high level overview of the system, and we'll be able to see that this report has been generated. And yeah, this time also it is whole, because the final result is consistent, and there are signals more or less similar to the previous one, but I think there are more number of signals and uncertainties this one. So yeah, so this is how the report generation works. And regarding the fixes, so regarding fixes, there were lots of problem with the requirement.txt. So what I did is the only uh, rec- fixed dependency that was mentioned there was that of QA. So I removed all the dependencies that was listed in requirement.txt in the given like folder that was given to me in the mail. So, and from there, this whole requirements, the TXT was created. And also there was lots of error in lots of wrong prompting error, like improper arguments, wrong imports, and all that kind of stuff. And tasks were also not assigned properly. Crew was not generated. Was also created in wrong way. So all those have been fixed. And then as for the edge cases, uh, like for corrupted or password protected PDFs, we are using PDF Plumber for that. So it handles that. So we pass the content and see if it's wrong, then we don't process it. Yeah. So from here, like you will be able to see that we raise exception for the password protected ones, or prompts or contexts that are too long. Um, then we also validate MIME type. We also validate the maximum upload byte size. We have maximum query characters also set for this. And yeah, uh, for documents larger than 100 MB, like we are filtering those out in the backend, and also in the front end side, we are filtering it out. So I guess it was in Mongo text, TSX, TSX. Yeah, so we are not allowing PDF max file size greater than max file size. And then there are for non-English financial documents also, like we are doing it inside the workflow PDF. So scan documents with we have already gone through it. Documents with complex, yeah, done. Concurrent file uploads from multiple users here. So for this, we have implemented async job processing, so it should handle it. And for network timeouts, we are using retries with exponential backoff. For memory execution, we are not loading memories that are very large. And for database connection failures during analysis. Yeah, so for this, we are for this also, we are using retries. And I think for this one, or yeah, this one, the job the job process like handles it pretty well. API rate limiter, we have properly we have handled the exceptions responses properly for those cases. Valid file formats are already gone through it. So yeah, course is also implemented properly. And one thing that is interesting is that this for the career, like we are using OPIC, and I think we will be able to see the traces for that. So this is the latest one that has been run, and in here, like you will be able to see the traces for it. So yeah, this is how the application worked, and this was the system design, the overview of the system, and yeah, thank you.